Okay, welcome to the Chapter 4, Class Level Methods and Inheritance, Section 3 of Chapter 4 Presentation Lecture. In Section 3, we'll talk about class level methods as well as some ways of inheriting some of those properties. Some actions are naturally associated with a specific class of objects. So, for example, what you need to think about is a person walking or possibly even a wheel rolling. We can write our own methods, which we've already done in one of our other examples and labs that you have been assigned, to define an action specifies class of objects, a class level method. So if we're going to apply a method to a class, it is a class level method. We are going to use an example called a skater example that we're going to use for today, and then also for our in-class example. So the question is, how can we create a skate method for ice skater objects? Okay, if we take a look at that problem, what we really need to do is we need to tell Alice to associate the new method, the one that we are about to write, with an ice skater, and then also write a new method to animate the ice skater skating. So essentially two methods here. Let's take a look and see how we're going to do this. All right, we'll take a look at the demo here in just a second, but basically what we're going to have is we're going to have an ice skater that's going to be the object in our world. First, we want to associate the animation with this ice skater. So we would select the ice skater in the object tree and then create a new method for the ice skater. If you remember back in our previous example, we were creating a method for the world. In this case, we're creating a method for the skater. So you click on the Create New Method button, you would title your method, and then we would be on and running. So if we take a look at the textual storyboard, we're going to title the method skate. We are going to drop a do together control structure. Within that do together, we're going to have move the skater forward 2 meters. And within that do together, we're going to drop another do in order. And within that do in order, slide on left leg, slide on right leg. Now the slide actions are going to each require several motion instructions. So we will break these down into actions into smaller steps. Well, you might be thinking to yourself, how are we going to do that? We are going to use what's called stepwise refinement. We've already touched upon this, but if we take the skate method, we are going to do together. There's the textual storyboard we just saw on the last slide. But then we're going to take the slide left and slide right, and we are going to break those down also into different methods. So refinement of slide left is do in order, lift right leg and upper body, move forward, lift right leg and upper body upright, or return to the body upright. So that's the slide left, and then slide right is lift left leg and upper body, move forward, and then lower left leg and return body to upright. So that's going to be those two methods which are going to apply to the class of object, to that class object. So to see how this is going to work, let's take a look at the demo. So the demo here it is. Okay, so if I hit play, so the skater's moving forward while the legs move. Now let's take a look at the code. So the code, we have the ice skater skate, which is this method here, which we have created. We have the ice skater skate. We have also slide left and slide right. These are all class level methods. So in this case, the ice skater skate is this. Ice skater move forward 2 meters, then slide on right leg, slide on left leg. These are methods in themselves. We break those down, you can see that there's a little bit more code here, and this is the reason why we create methods rather than having to recreate code. So that's slide left, or I'm sorry, that's slide right. And let's take a look at the slide left, which is the same thing, just with a couple opposites, so that the other leg moves. Okay, so on and so forth. All right, go back to the presentation. All right, so the concepts illustrated in this example, we can see a method is defined for a specific type of object. It's also going to define an action for that object. And then also we create a method that we can call other methods. In this example, we have created skate, slide left, and slide right. Now to reuse it, so if we write methods to make an ice skater perform a skating motion, it is an intricate task, which means that we're probably going to reuse some of these methods to continue the action. We would like to have the ice skater skate, in other words, without having to write these methods again. the idea of using this is we bring in the slide right and the slide left and we reuse them. The idea of being able to use previously written program code in another program is known as reuse. This is a very, very important concept for you to be able to grasp as a programmer, because the reuse of code that is already written is going to save you a lot of time and effort. All right, so let's take a look at our new class. If we were to create a new class, which means that we would bring in another object, we would rename the object, thus now we have a new object in the world. So if we inserted another skater, we would rename the ice skater as Clever Skater. We would then save out as a new class. Alice saves the new class, and it would call that particular class Clever Skater. Inheritance is a big part of Section 3, and this is one of the big things that you have to be able to grasp when you're going through the material here. Is the Clever Skater class is going to inherit, which means it's going to take on all of the properties and methods from the original Ice Skater class. And also, make sure that you realize that it has the newly defined methods, skate, slide left, and slide right, already associated with this new class member. In other programming languages, the concept of creating a new class based on previously defined class is called inheritance. And it's pretty much the same thing as if you were to inherit land, money, or something like that from a deceased member of the family. This is somebody, another class inheriting the properties of a previous class. So then we can then import the Clever Skater, because the Clever Skater already has these methods that we've already created and associated with this class, and insert them, or insert the Clever Skater into a world, and all those other methods will then come along with it. In the instance of the Clever Skater class can be added to the new world, we would use File and then Import. Now the guidelines here, to avoid potential misuse of class level methods, make sure that you follow these guidelines to keep from doing this. Avoid references to other objects. Avoid calls to world level methods, because the world is not going to be the same. Play a sound only if the sound has been imported and saved as part of the new class. If these guidelines are not going to be followed, you are going to actually get errors. The new class is added to another world. Alice will open an error dialog box telling you something is wrong. Okay, here's a bad example. Let's take a look at this code for the Clever Skater skate around. In this case, you're going to have a do in order with a do together inside of it. Clever Skater is going to turn and face a penguin. Well, if we import this class or this object into another world that doesn't have a penguin in it, how is Alice going to relate that in a new world? We don't want to have that in there. If there is no penguin in the new world, then we'd have to import it, or we would have to do something else. Okay, so the problem in this case is, suppose you really want to write a class level method where another object is involved. You can do this. So for example, a method make the skater skate around another object in this penguin. You can do this, and you can also have this applied to any object that might be in the world. How do you do this? You use a parameter. Solution is to write a class level method with an object parameter that allows you to pass a specific object into that parameter. So let's say, for example, we're going to write this method, Clever Skater, skate around. We are going to have a which object parameter in it. So then, once we write this method, we can use the parameter which object. Then when we import that particular object into the world, we can drag into the parameter the object that we want the Clever Skater to turn and face. That way it doesn't matter what object is in the world, we can apply it to anything. Clever Skater will move to that object, and Clever Skater will turn around that object. So if we translate this to code, most of the skate around storyboard design is straightforward and easy to code. One step, however, is going to require some thought, and that is, how are we going to use this parameter? So Clever Skater move to which object? What distance should the Clever Skater move? Well, as we know from previous chapters and previous examples, this is a time to use a possible function and or expression to move the skater the proper distance. All right, so what we're going to do is we're going to call a built-in function. The instruction to move the skater to which object, in this case it's going to be the penguin, is going to look Clever clever skater, move forward, and then we would drop in there the function of the clever skater distance to which object, which is the parameter. We can then drop in the penguin later. Now, unfortunately, the skater will collide with the penguin because the distance between the two objects is measured from center to center. So we have to include an expression in here so that they do not collide. Okay, so in this case, to avoid that, what we're going to do is we're going to use a mathematical operator and an expression to keep them from colliding. So we'll take clever skater, move forward, then the clever skater to the distance of the object that we go ahead and designate -1. That way they will not collide. Okay, so let's take a look at the skate around example and I'll show you what we've just been talking about. Let me open up that file. Okay, so here's the skate around program. Give me a little second to load here. Okay, now here we are with the parameter. Let me open up this method. So now we've created the parameter. Right up here is where we would create it. We click on create new parameter. We would make the parameter an object parameter. We would title it which object. Now, in which case we can pull this anywhere that we want, and what we can do is we can take the parameter and we can drop in whichever object into the parameter that we want. In this case, it would be the penguin. Okay, so let's go back to this is what it's going to, the which object, the parameter is going to equal the penguin. So we are designating the penguin to be in that parameter for this particular world example. All right, so let's go back to the code. So the clever skater is going to turn to face the penguin for a duration of 0.5 seconds. It's going to skate towards, skate forward 0.1 revolutions for a duration of 5 seconds. Then the clever skater is going to move forward and not collide with the penguin. Clever skater will then do 1 revolution as seen by the penguin and then turn backward. Let's see how it operates. All right. There you go. Using a class level method and a parameter to write code and make two objects interact with each other. Now, what you need to remember is that the parameter is going to act as a placeholder for whatever object we want to designate. A call to distance function is going to return a numeric value. A math expression can be created as part of the instruction within the built-in function in this example. All right, so if you haven't already done so, make sure that you read through Chapter 4, Section 3, Class Level Methods and Inheritance. Read through the tips and techniques, number 4, Visible and Invisible Objects. And then we will be going through and doing the lab for Chapter 4, Section 3. And then after we have completed that, we will be moving on to your first project that you'll be doing at the end of Chapter 4. Okay, so this concludes the end of the Chapter 4, Section 3 presentation lecture. I will see you back here when we start Chapter 5.